Hello students, welcome to our new video. In this video, we are going to learn in details about subroutine. So let's begin with the with the stack. What is a stack? Stack is a set of memory locations. So it is located in the memory, operating in a manner first in, first in, and first out. Okay, first in and first out. And if you store 1, 2, 3, 4, 2, 3, 4, get your answer in the form of 4, 3, 1. Okay, so let's get the idea. So for example, you've got the your message folder, email folder. Okay, all this works on the last in first out operation. Now see, let's get the idea of the stack clear. Okay, so this is your memory. Okay, this is your memory. This is your stack pointer. Okay, and these are the various elements. Together they are called stack. Now this is the top of stack. The top of stack. Okay. Address of the top of stack is given by the stack pointer. Okay. This address of the stack is given by the stack pointer. Okay. Writing address of the stack given by the stack pointer. And now what is stack pointer? Stack pointer is the address of the top of the stack. Okay. Understood? Stack pointer is the address of the top of the stack. So let's get clear. That stack is a set of memory locations. Okay, stack is a set of memory locations. It is present in the memory, right? But stack pointer is a register. It is a 16-bit register. It is present in the microprocessor. Okay, it is present in the microprocessor. It contains the address of the top of the stack. Okay, SP, it is present in microprocessor. It points to the top of the top of the stack. Okay, fine, clear. Now we'll be asking, why are you interested in the top of the stack? Because we do a push and a pop, which can only happen at the top of the stack. We're doing push, we're doing pop. Both can happen only at the top of the stack. Push a new element, it will come at the top of the stack. Pop an element, top of the stack of of all the elements present in the stack. That the one that will participate is push and pop in the top of the stack. Hence, SP contains the address of the top of the stack. So, push an element, it will come to the stack. You pop an element from the stack of all the elements present in the stack. The one that will come out, push and pop is the top of the stack. Understood? And a stack pointer contains the address of the stack. Okay, because in push and pop, both the instructions works on the top of the stack. So all these are the basics of stack. Okay. Now the first use of stack is store data. Okay, we'll now discuss about the uses of stack. First use is store the data. Okay, store the data. Now the most important use. Now this is the most important use of stack. Now tell me, where do we store data? We store data in registers, right? We all know that store data in all registers. In registers, correct? Now, what happens when you don't have unlimited number of registers? Don't have unlimited number of registers. You have only how many registers you have? You have only 7 registers. They are A, B, C, E, H, L. Okay, H and L. Okay, so if you just keep storing data in registers, you understand after a point all registers all registers will be full. Okay, now you will do programming. All these registers already occupied. Is it possible? So whatever data you have in registers, if you don't need it urgently, then just push it into the stack. Okay, just push into the stack. Whenever you want, get it back by pop instruction. Suppose your data is in BC pair. The data is in BC pair. You don't need the data right now. Okay, what you will do? You simply write push B. Simply write push B. Okay. So what will happen if you write push B? The data of to push B, you are simply pushing the contents of BC pair into stack. Okay. See here, contents of C here. This is the top of the stack. The contents of C is moved to SP minus 2 and it is SP minus 1. Okay. Now when this goes, now when I hope you remember push and pop in instructions. So once this is pushed into the stack, BC pair gets free, right? BC pair gets free because the contents of BC pair is stored in the stack. So the BC pair becomes free. Okay, so you can use it for anything. Okay, your original value is secured in the stack. Whenever you want the data back into the BC pair, you simply write pop B. Simply write pop B. You write pop B, then what will happen? The data of C will go to C register, data of B which was stored in the stack will go to B register. So what I'm trying to say is, if you don't need the data in registers right now, go on pushing the data in the stack. Okay, whenever you need this, get them back by using pop. Just keep in mind, if you push 1 to 3, you will get 3 to 1. Okay, that is last in and first out. I hope this is clear. So, do you remember call instruction 18 T states? So, just a recap. So, this is your main program. Okay, this is your main program. Right here, call. Okay, and then program continues. Now, this is your subroutine. Whenever you write call, go to the subroutine. Okay, so that execute the subroutine and return from the subroutine. You need and to return from the subroutine. You need a return, right? You need a return, and it returns to the next address of the main program. So I hope you are remembered. Now to invoke the subroutine, you write the call instruction, right? The you write a call instruction. So program will come up to here, right? We'll go to the subroutine. Go to the subroutine. Okay. Then it will execute the subroutine. execute the subroutine, execute the subroutine and come back the next instruction. Okay? Come back to the next instruction of the main program using return instruction. The return instruction. Understood? I think you already know it. You already know it. So now we must just write why, because this is the subroutine. It can be called from anywhere. This call can be used anywhere. So microprocessor should store the return address somewhere. Okay, it will store the return address into the stack because right now it does not require the return address, so it will store it in the stack. Push the value of PC program counter into stack by using push PC. Already know this, right? By using push PC. By using push PC. Okay. Now that means the return address will be stored into the stack. So after writing push PC, the return address will be stored in the stack. Right? Now the PC will get the address of the subroutine, execute the subroutine. On return, the return address will stored into the stack. The return address is stored in the stack. Now after executing the subroutine, it has to return to the main program. So what will happen? The return address will be simply popped back. So we'll write pop PC. It will pop the it will retrieve the return address stack. So, all these I have made it clear in call instruction. Watch the video before coming here. So all this was a step. Okay. Now something which we cannot do without stack register. That is read and write the flags. Okay. We read and write the flags. Okay. This is the thing which you cannot do without stack. Now see, now you know that F is not a general purpose register, right? F is not a general purpose register. It's a flag register, but it's not a general purpose register. Want the value of C register into B register. What I'll write? I want the value of C register into B register. So what I'll write? I will write move B comma C, right? Move B comma C. Now I want the value of F register into B register. I can F register into B register. So I cannot write. So what to write? Should I write? Should I write move C comma F? Is it possible to write? No, this is not possible. So F is not directly accessible by the programmer. You already know. But what if for some reasons you want to copy the value of flag register into some other registers? Now it is not directly possible. There is only one way of doing it. How? See, PSW. I hope you remember PSW. Okay, by using PSW. Remember, remember it is used only using in PSW is only using push and pop instruction. I have told you during the instruction. PSW is used only during push and pop instruction. So what if I told you push B? What if I told you push B? Push B, then sorry, push PSW and then pop B. Okay, so let's see what's happened. What is PSW? It is the combination of accumulator and the flag register. Okay, it is a combination of accumulator and the flag register. Now this will be pushed into the stack. So next I have written pop B. Okay, so next I have written pop B. That means I am popping the the data of the into BC pair. After push B, the status of the flag has gone to the status of the flag has gone to the stack, and the contents of the A has gone to stack. Right. So after I write pop B, what will happen? B will get the value of A and C will get the value of F. Right. C will get the value of A and F will get the and F will get C will get the value of F. So now getting the value of A, now B getting the value of A is easy. You can also write move B comma A. Okay, but C getting the value of F next to impossible. Can you write move C comma F? Can you write it in normal way? No. So there is no other way in 8085 by which you can uh, read the flag register. This is reading the flag register, right? You are reading the flag register by this PSW. Okay, this is your only option. If you ever want to get the value of flag register into a user register, you should always write push PSW and then pop it into another register. Lower byte in the register pair will get the value of F like shown in the example. Okay, I hope this is clear. You have seen how to read the flag register. Now I'll show you how to write in the flag register. Suppose I write B, push B, and then pop PSW. Okay, so you are pushing the value of BC pair to stack. See here, so this is your stack. So pushing the value of BC pair into the stack. Fine. Now A and now pop PSW. What is the next instruction? Pop PSW. Okay. So you can uh, uh, you can also do it. Okay. By uh, A will get the value of when you do PSW. A will get the value of B and F will get the value of C. Okay. A getting the value of B is very simple. You can also write move A comma B. Okay, but F will get the value of C. Can you write move F comma C? F will get the value of C. No, it is not possible. Okay, so no other way in 8085 by which can we could have done this. You have now a brand new value to flag register. If you remember, flags are changed on by the ALU after every operation. Now, if I ask you 25H into the flag register, how will you write? How will you write? The question is, the question is, I ask you to put 25H to flag register. Okay, how will you write? First, I'll write MVI C comma MVI C comma 25H. Okay, that is C is getting the value of 20, C is getting the value 25H. Then I'll write push B. Okay. Then I write pop PSW. Push B. C is equals to C becomes 25. Push B. What if I write push B? What will happen? 25H will come into the stack. This is B. This is your 25. If I write push B, this 25 will come into the stack, right? This is your stack. Okay. If I how will you change now? Pop PSW. Next is pop PSW. So 25H will come into the flag register. Your PSW and F 25H has come to the flag register and the content of B has come to the A register. Okay, so this flag register will now contain a new value 25H. Can you do change the value of the F by any other instruction? No, this is only possible by push and pop. Okay, so please tell me, do you understand this? To read from the flag register and write from the flag register, this is only possible using stack. Okay, now the fourth one. The fourth use of the stack is to pass parameters to subroutines. Okay, to pass parameters to subroutines. So right now I will leave as it is. I will not explain here just right now. At the end, because you don't know what are parameters. Okay, so at the end I will explain this with an example. So next I am going to teach you subroutines. So then you'll understand what subroutines are. What is the meaning of passing parameters to the subroutines? Okay, so skip this for now. Okay, so let us first see what are subroutines and what are parameters. Understood? Now, what is a subroutine? Subroutine is a function. Okay, I've already told in the previous lecture. Subroutine is a function. In a program, if there is any operation that needs to be operated again and again, like multiplication. Okay, for example, multiplication, you have to multiply again and again. Okay, 8085, there is no mul instruction. Okay, there is no instruction called mul. So you have to write a loop where you go on adding the number multiple number of times. In 8085, we are multiplying the numbers by adding the number multiple number of times. Okay, so you are multiplying a number. You are multiplying number in a part of the program. So then then some other part, that is different portions of the program, you want to do the same section. One option, it means if you in the whole program there are several steps where there needs a multiplication program. Okay, so one option is that you write and copy write once, copy paste again, and the copy paste the same multiplication program. But that is not accepted. So if you know you want to do it again and again, you can just create a function. Okay, from wherever you want to do, you just call the function. Okay, first create a multiplication program. Okay, and just call that subroutine or function whenever you need it. Okay, so it will find the multiplication program and then come back to the main program by using the return instruction. Okay, come back to the main program. Okay, again call it whenever you again you can call the same function whenever you need it. That is how the size of the program gets reduced. Understood? See, subroutines are used because they are they can easily manipulate whenever necessary. Right? So now I'll teach you how to pass the parameters. I think you understood. This is nothing but if you want to create if you want to call a function multiple number of times, you can just write a subroutine and you can call it several times when you need it by just writing call. Or if you write call subroutine, it will execute the subroutine and it will return to the main function. Sorry, main program. Okay, using by using the return instruction. Okay, I hope this is clear. So now I'll teach you what is a parameter. Teach you what is a parameter. So you have written a function in C programming, right? To find out the factorial, you have already learned the factor how to find the factorial in C programming. Now this is your whole program. Now this is your whole program. You have you have made a function by the name fact, right? You have made a function named by the name fact. As an example, you can you know how to write it. Okay. Now suppose your function finds factorial of 10. Whenever you call this function from your program, it will give you the factorial 10. Suppose you have written a subroutine by the name fact. Okay, it will give you the factorial of 10. Okay, now from the main program, you call the if you call the subroutine, every time you call if you call it, it will give you the factorial of 10. Okay, but what if you but what if you want to find the factorial of 20, 30, 40? Are you going to write different functions for them? No, because the method of finding factorial same for every number. So why I create different functions? Why not create a general function? So instead of finding factorial 10, we'll find factorial of n. You find the factorial of n. Then you write the body of the function. Okay. So whenever you are dealing, you are calling the function, you write the factorial in the bracket. You write your program, but say 10, 20, 30, etc. Okay. You can write pair 20, 30, whatever whatever value you want to find the factorial. Then you can you have to mention the number for which you have to find the factorial. Okay, and just call that function whenever you need it. Okay. So a value is passed by the main program to the subroutine. Told you how the value is passed to the subroutine. Suppose if you uh, if you write fact you write fact 10. Okay, that 10 will go to the subroutine. Will go to the subroutine. Okay, and the subroutine will find the factorial of 10 and it will come back. Okay, it will come back to the main program. Understood? Similarly, if you want to find the factorial of 20, you have to write fact 20. It will go to the subroutine and it will execute the subroutine. It will find the factorial and it will come back to the main program. Understood? So it is so how do you pass your parameter to the subroutine is what you are learning. Okay, this is the way. Now to give the value to the main program, you need to store the value. So the first method of passing the parameter is using registers. First method of passing the parameter is using registers. Okay, using registers. Okay, suppose this is your main program. Okay, then I have written mvi mvi b comma 25 h. Okay, then call sub. Okay, then this is some random instruction, then called. Okay, now what is the value of what is the value of parameter, and I passed it using what. Say what is the what is the first line of the subroutine. Call the subroutine here. I have written move a comma b. So what is the first line I have written in the subroutine? uh, the move a comma b. Okay, that means if there is a subroutine to find the factorial, it will first it will find factorial of any number present in b register. Okay, it will find factorial of any number using in b register. Okay, so I have put the value of 25h into b register. So how the subroutine will find the factorial of that 25h? That means the parameter 25h passed to the subroutine using b register. Okay, the parameter, I am repeating that how the subroutine will find the factorial of 25h. That means the parameter will 25 the parameter 25h first first have initialized 25 into b, then I have written move a comma b in the subroutine. That means the parameter is passed to the subroutine. Okay, so what do I do? MVI B comma 35h. Then I have called the subroutine. You go to the subroutine. Okay, okay. But now, on all find the but you go to the subroutine. But now but on you'll find the factorial of 35. That means you are passing parameters using registers. That is the method. Okay. In this but you can also in this way. Here you will find this factorial of 25, but you can, if you write mvi b comma 35h, you will find the factorial of 35h. Okay, so this is that, so you are passing parameters using registers. So that is the method of passing parameters using registers. Now if you want to find the this is the way of finding the sorry, what this is the way of passing parameters to the subroutine. Now if you want to find the simple interest, you need to pass three parameters, right? Because for simple interest you need three parameters, p and r, right? p and r. Okay, so you have to pass three parameters. Now what you have to write? MVI c comma 25h. Suppose MVI a comma h comma 15h, and MVI b comma suppose 06h. Okay, so these are the three parameters you have to pass to the subroutine. Okay, so you will put these three parameters in three registers. Just I put in three, you have put the three parameters in the three registers. Okay, now the subroutine will go on taking the parameters from the registers one by one. Okay, you will pass the parameters to the subroutine. So the subroutine will take the parameters one will the subroutine will go on taking the parameters from register to from the registers one by one. Understood? And we'll do the operation on that. Clear? So you can pass multiple parameters. But how many? 2, 3. What if I want to pass 10 parameters in a single call? There are not in a single call. If I want to pass 10 parameters, here you have pass 3 parameters. It's okay. But if I were to, because I have 7 registers, so this is you have passed 3 parameters. That is okay. But if I want to pass 10 parameters using a single call, okay, this will not be possible because that will block all the registers. So how we are going to use other registers? So using this method, you can pass at the most one or two values. So using this method, so this is the simplest method, but it cannot pass multiple method. So this advantage can be advantage will be can be overcome by using memory. You have 64 you have 64 KB memory because and you should pass and you should pass parameters you want. So what are the parameters? Which parameters you are using memory? So to pass the parameters, we are using the memory. Okay. So to overcome this drawback, so that you can pass multiple parameters, we are using memory. Now the second use is using memory. So this is your main program. Have written MVI A, 25H. Okay. Then I have stored A 1000. Okay. Then I have called the subroutine. Okay. And then called. After calling the subroutine, it will go to the subroutine. Okay. Here LDA 1000H. Then the program. So every time we look at the first line of the subroutine, it will tell you the story going on. LDA 2000, that is A is what is happening in LDA 2000, that is A is getting the value of 1000. The data stored in memory location 2000. So where is the provision example using register? Register A is taking something from register B, right? The register A is taking some in the first example. The register is taking register B. There is no provision of using register. The register is taking something from register B. So in the first example, you passed your parameter using register. The second example, you passed your parameter in a memory location. Okay, understood? So in example 2, your parameter is 25H. So you passed your parameter using memory location 2000, right? In this example, you passed your parameter using 1000. Now put your value in the register A. Okay. Then to memory location 1000. This is because you cannot store 25H directly into location 2000. So you just store it in A. Okay. And store it in the location 2000. Understood? So now you see here you are not blocking any register. Only you are storing in register A. It gets transferred to some other location and A gets free. So again you can store some other data and store it in some other location. Understood? And understood? I'm repeating again. In example 2, you passed your parameter 25H. Okay, you using a register in the first example. In example 2, you passed your parameter using memory location 2000 days, right? You have passed in A the data stored in 2000 location in register A. Okay. Now you put your value in and then to memory and then to memory location and then and then to memory. This is because you cannot store 24. You cannot store 25 each. So you cannot store 25 each directly into location 2000. So now you see here you are not blocking any. So you are not blocking any register. At the previous example, you are not blocking any register. Okay, only you store in register A. It gets transferred to some other location. A gets free. Okay, A gets free. Now you can store some other some other data in that location. Store it in some other location. Right? Let us see an example. Let's see an example. MVI, comma 25H, STA 1000H, MVI, MVI A, comma 45H, A 2001H, okay, and then STA MVI A, comma 35H, and STA A STA 1000 STA 2002H. Okay, then you call your subroutine. Okay, then you call your subroutine. If you go to subroutine, now you go to your subroutine. Okay, in subroutine, it has been told that LDA 2000H. LDA 2000H. Okay, now LDA 2000H. Now what will happen? First of all, you see you have passed three parameters, right? 25, 35, and 45. Okay, 25, 35, and 45. Okay, as very you can pass as many parameters as you want. Now LDA 2000H. Now it will go to the subroutine. Okay, remove the parameter, the operation, and remove the parameter and do the operation, and so on. So it will remove the parameters and it will come to the back to the main program. Okay, so all that I am trying to say is you can pass as many parameters as you want. You are not blocking any parameters. So advantage of this method is you can pass multiple parameters using this method. But drawback is rigid. Drawback is it is rigid. Why rigid? This is a subroutine. Okay, this is a subroutine. What does the method say? Passing parameter using memory. This subroutine is talking to the is taking the parameter from memory 1000, right? That means who, whoever wants to use this should keep 2000 as variable for passing the parameter. What else if we have already used 2000 for something? in your program. Now you cannot use the subroutine. Subroutine dictates it will only work at memory location 2000. So now this is contradictory. When I say memory, it should be you should always do it anyway. Uh, uh, Now 2000 on now only 2000, but not only 2000, but you want to use any memory in a more flexible way. What is the more flexible way? Because it works in fixed memory location and using memory point. So understood? Because it works on only 2000, only 2000. That is the main drawback. Okay. Otherwise, this method is good enough because you can pass multiple parameters using using this method. Okay, but you have to specify that this method will work only on memory location 2000 each. Okay. Now the third example is using M, using memory pointer M. Okay. Now LXI H comma 1008. Okay. Then MBI M comma 25H. Okay. Then I will call the subroutine. Okay. And then halt. Okay. Call the subroutine move A comma M, and then turn. Now you see HL HL 2000. Okay. This 25H. Now I'll tell you what is the question is what is the value of A. Okay. Now 25H, this 25H is passed. So is passed using M pointed by HL pair, right? M pointed by HL pair. M means 25H at the location stored at 2008. So 25H is passed using if memory pointer HL pair. So, so what did I say? The key to understand is to find the line of the first line of the subroutine. The first example, subroutine takes the value from B register. In second example, subroutine takes the value from a fixed memory location. In this example, the subroutine takes the value of from M, right? Takes the value from M. First you have a initial HL pair, then you have since you have initial HL pair, M the memory log is the data pointed by HL pair. So 25 is passed HL so through M, the value from M. So what is the difference in the second example 2000 days and in the and M as an as M is also a memory location. Difference is in the first case it works only on in the second example it works only on memory location 2000 each, but in the second one it works only on memory location decided by the program. Okay, if you want to change LXI age 2000, there will be only difference because the subroutine will take none from 3000. Unlike second example, M can be used locating pointed by HL pair. Okay, you have used control over subroutine while calling the subroutine. You as the you as the you as the caller. This is a function. I choose what is the parameter where to pass it from. I memory location the seventh if memory location 7000 is free, then you can also write Alexa H 7000. So all these depends on the user. Okay. Now put the value anywhere in M. Whatever the parameter you put taken by the subroutine from memory location 7000. So, so you can take any value from memory location to the 7000. Okay. As per your choice. But in the second example, you have to take value from 2000 only. Okay. The was is wonderful because you can pass parameter using memory location decided by you at the time of calling. You can pass here parameters like Alexa H, 1000H, MVI, M, 25H, then INXH, then MVI, M, 35H, then INXH, and then MVI 45H. Okay, so this is the first parameter passed. Okay, then I've incremented the HL pair. I can increment the HL pair, and then this is the second example that I passed, and then I again incremented the HL pair, and then this is the third example passed. So you passed 25, 35. So you passed 25, 35, and 45 as using location 3000, 3001, and 3002. Please go on passing as many parameters as you want. Please tell me, did you understand? But drawback it blocks the drawback is blocks the HL pair. Okay, you see you see in first example, in order to pass a one parameter, you blocked one register, two param the two parameters which the two parameter sorry two parameters, two registers, three parameters, three registers. Here no matter how many parameters you pass, you are blocking only two registers which we can pass before of we can pass of parameter, we can pass n number of parameters. It is flexible. Okay, we are blocking only we are blocking only two registers, that is H and L. So last and the final one, passing parameters using using stock, which was skipped in the first example. Just skipped in the first example. So before you go, let's understand the simple program. The question is, what is the value of A after the program is over? These are typical exam questions. They will see they will see you as a programmer, and and tell you and will tell them what is the value of a register after so and so program. So let me give you the program. MVI A, 40H, okay, and then ADI 50H, LXI H, 2000H, then INR A, then called subroutine, okay, and then called. So when I go to the subroutine, for H, then PCHL, and then MVI A, 55H, and then return. Okay, we are going to the subroutine here. Okay, and then after return it comes to the next instruction. So now what the question is, the questioner the examiner will take your exam. he or she will ask you what is the value of a here. What is the value of a here? Okay. What is the value of a here? Now see, now call a subroutine pop it. What is it? What does it do? It pops the data from top of the stack to HL pair, right? Pops the data from the top of the stack to the HL pair. But we have not you pushed anything, right? What have happened then? Push has happened. How? Whenever you do a call, there is a push. It has the push has happened. How? Whenever you do a call, there is a push. I hope you remember the address of the next instruction, which was there in PC. If a push there is a push p, that is push PC called as a push PC. That means the return address was stored in stack, of course, into locations. Now, first one of the subroutine is a disaster. This is a disaster. Okay, so because you so far so the return address is HL pair. So the return address is no longer in HL pair. It is in it is in HL pair only. Okay. Now you write PCHL. Such a cute little instruction, but it is it seems it is harmless, but it is not. PCHL gets the value of HL. Now HL address has the return address, means PC gets the return address. Understood? Suppose A is for 98, the ADI 50 means 90 plus 50, sorry 48, that is 40 plus 50 is 90, A is 90, then LXI 2008, this is used the reference only for confusing you, then INR A becomes 91 and then you call the subroutine. Now pop age. What does pop age will do? It will take back the HL pair from the take the value of the HL pair from the stack, right? And PCHL. What does PCHL do? PCHL will copy the address of HL pair into PC. So you got the return address, right? So these two instructions will not be executed since these two instructions will not be executed since we have got the return address. So it has come to fault. Understood? Now HL address the now PC gets the address of the next instruction. That means that it will directly come to halt. Halt and MVI A55H and return will never be executed. Okay. So please tell me, did you understand? Now what was the last value of A? 91. So I hope you understood. So answer is so the value of A is 91. Okay. So the value of A is 91. So the last instruction passing parameters to stack. So we are learning answer that we left. Now it is understood what does now I hope you understood what does passing parameters mean. But let's get into the sample program and understand it and understand it. And understand it. The question is, what is the value after programming? MVI MVI A comma 48, then then ADI 58, okay, then LXI H comma 2008, then INR A, then call subroutine, okay, and then halt. Okay, call subroutine. The subroutine is pop H, then PCHL, and then MVI A comma 55 H, okay, and then return. So what is the value of a maximum will tell the answer is 55. So let's go to the subroutine. Pop H. What does pop H do? Pop it pops the data from the stack into HL pair. What is there in the top of the stack? Since when we have not pushed anyone, what are you popping? Whenever you make whenever you use call, remember there is a push. Push means the return address is pushed into the stack register. Pushed into the stack register, right? It means it is popping the return address to HL pair, right? This pop page, it is uh, since during call we are pushing the program counter into the stack. By pop page, you are retrieving the HL pair into the into the stack, right? Into the from you are pop page. What does it do? It gets the value of HL pair from stack, right? Gets the HL pair from stack. Okay, this means then the return address is now in the, that means the return address is now in the sorry, then we have now you write PCHL. So PCHL, PC gets the instruction and gets the instruction and so of getting the value of HL pair into PC. Okay, HL pair into PC. So PC has got the return address now. So when it has got the return address, it will not execute instructions. Okay, this will not execute these instructions. It will directly come to the fault. So when you write PCHL, PC gets the value of HL. HL has a return address, which means PC gets the return address, that is gives the address of the next instruction to be executed. That means the program will take shortcut and directly come to the next instruction, that is halt. These two lines will be not be executed at all. So what is the final value of A? The final value of A is 91. Have you understood? So this is the process of how we are passing the parameters by using registers, using memory pointer, and using memory. Now, what you have learned from the example, whenever you use pop in the beginning of the subroutine, the moment you have used pop, you have removed the return address from the stack, right? Pop means you have removed the return address from the stack. Suppose you have returned the address. Remove the return address uh, from the stack. For example, about PCHL, suppose you have removed the return address once from the stack, then A would be 55. Now what does return do? It takes the return address from the stack. Now there is no return address, right? There is no return address. It is the after writing, for suppose you have not used PCHL. The instruction you have not used PCHL. Now the pop page, it will retrieve the return address from the stack, right? It has retrieved the return address from the stack. You have this return address from the stack. Okay. So you have not got the you have not used PCHL. Then what was the instruction? The instruction was the MVI a comma 55 each, right? And then return. So A would have got a 55 each, okay, but return. And then we have come to return. But where is the return address? The return address has been popped out from the stack. We have put the return address in the stack. Now we have popped out the return address on the stack. Now where is the return address? I hope you understood. Now I'm teaching how passing the parameters using stack. Now see here. I hope you understood the passing of parameters using stack. I will teach you now. I will teach you now pushing passing the parameters. Okay. So this is your main program. This is LXI, comma 1000, then push B. Okay. So 2000 is the parameter that I want to pass, and then and when there is a push B, you have pushed the BC pair. You push the BC pair. This is the top of the stack. This is the this is the value of B, that is 20. The value of C is 00. Okay, and this is the higher byte, and this is the lower byte. Understood? So this is how 2008 is pushed into the stack. This is the top of the stack, I already told, and this is pushed into the pair is pushed into the stack. Okay. Now, when you go to the subroutine, you want to set the parameter pack in 2006. So you used pop each. Okay. Now what are you saying to get? What are you going to get? Did you get the parameter? No. I have already told, when you push the parameter, there is another push during call, that is push PC. It is the parameter. It is the parameter. Used by the microprocessor. Microprocessor will push the return address to the stack used by the will stack used by microprocessor. Microprocessor will push the return address to the stack. That return address will come above the stack. Understood? That return address will come above the stack. Okay. That return address has come above the stack. This is the return address. Okay. The, and then access the parameter. So first pop page, get the return address and address it to the get the return address and address to the HL pair. Now first you do pop page. Okay, get the return address to the HL pair. Get the return address to the HL pair. Which is the return address? 20 return address is 1000 H. You get it into the HL pair. Okay. Now first for now get the return address to the HL pair. Now you do pop B or anything. Now you do pop B or anything. Get the parameter into the register. So you do pop get into register into register pair BC. Okay. So pop B, get the get the parameter into register pop B. You do pop B or anything. Get the parameter anything. So get the parameter into the register. Okay, the register pair BC. Now neither your parameter nor return address is in the stack. So you have put the in BC pair. You have got the return address. Okay. Now neither is a parameter nor your return address is in the stack. To come back using the option of PCHL, PC will PC PCHL will have the stack. Come back using the option of PCHL. PCHL will get the return address from the HL pair. PCHL will get the return address from HL pair. Okay, and and it will come back after it gets the return address. It will come back to the main program, that is halt. So, so now you understood why we skipped in the previous lecture, because you have to know how to pass the parameters in a stack. So hope you have understood very well. Happy learning. Hope you understood enjoyed the learning. Stay well and blessed. And if you have any program and any problem in understanding, so ask me in the class. So what you have learned today, we have learned what is stack, subroutine, what are the uses of stack, how to pass parameters using subroutine. In just have a look. Like, if it is any doubt, please ask me in the class. Okay, during the class sessions. So stay well and goodbye.